Hello everyone and welcome to the video. I'm Sabiya Mulla and today I'm gonna explain you what are motors, the classification of motors and principle of operation of three-phase induction motor. We all know that motors are heart of electricals, or we can say one of the main study area in engineering, especially for the students pursuing degree in electrical engineering. So we must first know what are motors and how are they classified, or the basic concept behind it. Basically, motor is a device that converts electrical energy to mechanical energy, or a device that works on electricity to produce equivalent mechanical work. The main two categories of motors are AC motors and the DC motors. AC motors are the one that work on alternating current and the DC motors are the one that work on direct current. The AC motors are classified as synchronous motors and the asynchronous motors, and the DC motors are classified as series, shunt, compound, permanent magnet DC motors. We all know that AC supply is classified as single phase AC and three phase AC. Hence, the AC motors are also classified as single phase AC motors and the three phase AC motors. Now, we'll move towards induction motor. What is an induction motor? Induction motor, which is also called as a synchronous motor, is an AC electric motor which has two basic components, stator and the rotor. The rotor is the rotating part and the stator is the stationary part which consists of windings. The rotor is rotated due to the torque produced by the stator winding due to electromagnetic induction. Induction motor was invented by a genius scientist Nikola Tesla in the year 1887 and it proved to be a revolutionary invention. Recently, 50% of the electrical consumption is done by induction motors and 90% of the industrial motors are induction motors. Now we'll see the types of induction motor. As the induction motors are AC motors and we all know that AC is classified as single phase AC and three phase AC, the motors are also classified as single phase and three phase induction motors. The three phase induction motors are again classified as squirrel cage motors or one rotor type motors. Now we'll move towards the principle of operation of three phase induction motors. It works on the principle of electromagnetic induction, where the relative motion between flux and rotor caused by rotating magnetic field induces the current in the rotor, forcing it to rotate in the same direction. The flux is constant, but its position changes in circular manner. When the electricity is supplied to the stator winding, which is three-phase winding, the current flows through it. The three phases of the stator windings are 120 degrees shifted from one another, and hence alternating flux is created. When this alternating flux gets linked with the rotor, according to Faraday's law of electromagnetic induction, it induces EMF in it, and hence current starts flowing through the rotor. But according to Lenz's law, current flows in a direction such that it opposes the cause producing it. And here, the cause producing current is nothing but the alternating flux, and hence rotor tends to oppose the flux, which means it tends to reduce the relative speed between rotor and flux. And due to this reason, rotor rotates in the same direction as that of stator flux. The flux rotates at the speed known as synchronous speed, which is given by n equal to 120 f by p, where f is frequency and p is number of poles. But the rotor always rotates at the speed less than synchronous speed. Now why is this so? The rotor always tends to catch the synchronous speed but never catches it, because if the flux speed and the rotor speed becomes equal, then the relative speed will be zero and the current induced in the rotor will no more oppose the flux and hence the motor will stop. Therefore, motor runs due to the relative speed between the rotor and the flux. Hence, the rotor never catches the synchronous speed. Hope you guys have got the concept of principle of operation of three-phase induction motor. Please do like, share and subscribe. Thank you.